Sorry for the interruption. I accidentally hit the wrong button trying to shush the peanut gallery at the house. So we're going to have two pieces to this, charging, and now we'll do discharging the capacitor. So instead of looking at the table that I have in terms of the current and the voltage on the resistor and the capacitor over time when we start to discharge, so this would be an interruption in the power source, or I've just removed the power source. So let's think what's going to happen on the capacitor. I've fully charged it, and I am looking at what's going to happen when I start to let that charge go. So I can look kind of up here what I wrote in terms of my current, remind myself. So at t equals 0, E becomes 1. So I would be at a maximum. So I would have the maximum, the maximum amount of charge at time 0. And then I'm going to have an exponential decrease in that amount of charge. The battery or voltage source, same thing, the voltage drop across the capacitor, it is going to be the voltage source. Remember, it stops charging when it equals the voltage source. And what's going to happen there? Well, it's losing charge, so it is decreasing in the amount of potential. Just the same, just think of it, just flipping it from what happened when we were increasing the potential. Now I'm letting it discharge, so I'm decreasing. So what's happening with my current? Let's see. If I do this choice, I'm saying current is at a maximum at time t equals 0. What t equals 0, there is no current, so that's not possible. That means that my current is increasing with time. So it's going to be like my I max times 1 times minus e to the negative t over tau. So if this is happening with my current, we define the voltage drop across a resistor in terms of current and the resistance. So the V on the resistor is going to be the max voltage drop. Let's see, and it's increasing. I don't know why my brain just suddenly didn't like this. Let's see. I feel like I just did something wrong. I'm increasing. Okay, 1 minus e to the negative t over tau. Yep, okay. Because at time t equals 0, this becomes 1. 1 minus 1 is 0. So I have no voltage drop originally. Now I feel better. At first I was thinking of it as maximizing. So my suggestion to you is to keep this sheet handy to refer to. That'll help you keep straight what's happening on our resistors and our capacitors as we talk this through. So, okay, let's go back and label in our current and our voltage over time. Let's start with the current. So right after the power source is removed, what do we have? We have 0. And then the voltage here would be 0 on the resistor. The voltage on the capacitor is the same potential as that from the battery or power source. After a long time, this is the one that gets a little tricky when we talk about discharging. Because in one way you can think about it, if I have a closed loop where I'm just going to continuously go back and forth and back and forth and back and forth. Well, we can see I'm going to hit a max amount at, over here, at t equals about 5 tau. So in terms of time, we look at this and we say, okay, so at t equals 5 tau, then this thing, I'm almost at like 95% of the voltage across the resistor. And so my B on the capacitor now is 0, and we say that this is now V battery, and then I naught. In reality, we have this thing called leakage. And so if your intuition is that if there's nothing to keep that cycle going, it feels like it's going to wane down to zero, you would be correct. For the purpose of this course, you can just think of that we're going to limit that time. So after a long time, we're saying that we've satisfied this. This is what we're talking about in terms of long times. Just kind of keep that in mind. Okay, so now let's do some math with this. And for that, I think we'll go ahead and move on to the next video.